So I hope that you guys can hear me now. It's okay. Can you give thumbs up or at least comment if you can hear me? Yes, all right. Right. Thank you for the comment. Right. So, very good morning. Assalamualaikum. Can the camera tune to me? Right. So, yeah, okay. Okay. Right. So this for today, what we would like to do is that firstly, I just want to show you what is our current status right now. Right. So currently, as being mentioned, okay, so as you already seen that currently we are in week 7, okay, lecture 7, which is on LAN technology, okay, where actually we need to do a test one that comprise of 25% of your assessment, okay, but it's already postponed to 28th of December, right? So it will be online, and the details you can see in MLS, okay, being mentioned by Dr. Khairil. Okay. So the rest of the thing that we already cover is that we already covered chapter 1 until chapter 6. Okay. So for today, we would like to look into chapter 7, right? And for my tutorial class, okay, I've covered until lab 5. Okay. So those who are currently in my lab session and in my tutorial session, so you are already on lab 5. Okay. So next week we have a midterm break, okay, and then you will be coming over again, right? To answer your curiosity, am I talking to myself? Yes, because there's no physical student. So perhaps everyone is already at home, because I'm sure that some of you are currently down to fever, or perhaps there's increased case of COVID-19, then it should be okay. Okay, it's okay. But to answer your curiosity, it's actually I'm alone here. Okay, right. So let me close this down, right? And before we start, I just want to play one video that I think is be very good for us. All right. So watch this. All right. That's a very quick video where this video shows us about internet. Okay. So what we would like to see later on today is what we call a standard called Ethernet, okay? And also another one is called Wi-Fi. So that's what we basically will cover for today's session, right? And again, before we move on, I just want to share with you some of the standards that you can see for Ethernet and Wi-Fi. Okay. Right. So these are few standards that relate to what Ethernet. Okay. Here we will later see that in Ethernet communication, there's few standards that can be identified. Can I make this figure? Right. So we'll see later on the slide itself that we will have these different standards, okay, where you have three components of this standard. And another thing is that you will also see that this standard is actually within the group what we call 203, okay, standard of 203, 802.3, sorry. If I can show you where's the 802.3, let me show here. It's okay. Later I'll show you. Okay. So based on these different Ethernet standards, okay, and there are a few three components made that you need to understand. Okay. You have the first one as 10, 100, 1000, and so forth. Okay. So basically, these are the speed the internet can support you. And then you have base. Okay. You can see base, meaning that this is a base line communication. Okay. So you can search for what does baseband means. Okay. And what's the difference between baseband and broadband? Where baseband basically is a digital type of communication where you can actually transmit it with respect to the medium of transfer, but only one signal at one channel. Use the whole bandwidth. Okay? Whereas broadband, the definition itself is can be analog, which you actually can multiplex different signal into one signal that frequency band, and then you can transmit it multiple user on a single channel. Okay, so the second part is base. Then you have these different 5 to TX, FX, SX, and so forth. Okay, so there are few different this. The third one will be representing what will be the interface. Okay, so coming back to like 10 base 5 here, the speed will be 10 Mbps. Okay, same goes for the other 10 base. Okay, so 10 Mbps. Then you have the 100 base. Okay, so you have 100 Mbps, and then 1000 base. Okay, so you will have 1 gigabit per second. Okay, so the first terminology will represent the speed. Okay, and then the distance will that covers it. Okay, some of it can be identified like base 5 and base 2. Okay, the 5 means that it can cover up to 500 meters, and base 2 means that it can cover up to almost 200 meters. Okay, then the rest doesn't represent any distance that it can cover. Okay, but the rest will be representing like the T will be based on what we call UTP cable. Okay, twisted pair. Okay, so it's using T is twisted pair and TX also a twisted pair. Whereas FX will be represented that you are using optical fiber. Okay, then you have the TX. Then you have SX is also optical fiber. This is for short distance. Okay, so and it will give you some indication of what is representing. Okay, So that is the Ethernet cable standard that we will see later. Then in the same time, you have what we call Wi-Fi standard, right? So in Wi-Fi standard, if you have seen this, too small, perhaps this would be better. Right. So as mentioned just now, for Ethernet, the standards that being used, the name or the term that it used is Ethernet 802.3. Whereas for Wi-Fi, you will see that it's 802.11, and that's different family of this 802.11. Same goes for Ethernet, it's 802.3, and they have different family members. Okay, so the one that we can see is start with 802.11. Then we have the 11A, 11B, 11G, 11N, 11AC, and 11AD. Okay, so why the difference between this is that it has different frequency band that we use. It has different speed. Okay, and it has some backward compatibility, right? Okay. So going on from 11 to 11 AD, basically you can see that it improved in the speed of its transfer. Okay, it goes from 2 Mbps up to 7 gigabit per second, and then from 11 up to 80, you can see that the frequency band can actually occupy both three different frequency up to with 80 you have 2.4, 5 gigahertz, and 6 gigahertz. Okay, so you start with 2.4 gigahertz, then you have the 5 gigahertz, and now we also introduce the 6 gigahertz in 11 AD. Also, what you can see is that Wi-Fi logos. All right. So basically, right now, if you look at the logos of some of the where's my logo just now, it goes out of reach. Logo A B A B A C. Okay, but basically you will see that the this one. Okay, so right now, if you purchase any of the wireless access point, basically you will see this logo where it mentioned that for Wi-Fi, this is the standard. It can compatible to A, B, G, N, and AC. Okay, so this represent that you can actually use the same Wi-Fi with backward compatibility. Okay, so we will see these two in a short time. Okay, so coming back to my notes. Okay, so for today, we will see on LAN technology. Basically, LAN stands for local area network. Okay, we already seen that we can have the network being configured or being classified based on the distance. Okay, So the first that we already see is what we call personal area network, shortly known as PAN. Okay, where then we have the local area network. Okay, then on a bigger scale you have the metropolitan area network, and the largest scale will be the wide area network. Okay, so we want to touch more about the local area network. Okay, so here when we talk about local area network, we can subdivide it into wired and wireless, right? So we have the wired LAN and the wireless LAN. And with respect to that, we can see that for wired LAN, the most protocol that being used, okay, widely used is the Internet protocol, okay? And then you have the wireless LAN where the most protocol that being used is Wi-Fi. Okay? Okay, so for today, we will cover on the Internet part. Okay, whereas in Internet, we will look into that of the local link control and medium access control. Okay, and then identify different Internet protocols that I've already shown to you just now. Okay, discuss the importance of wireless LAN, also the standards that already been shown to you, the different type of standard. Okay, which the for Wi-Fi, it's being identified. The basis is 802.11 families. Okay? And also, you can have what we call Bluetooth, and the standard being defined as 802.15. Okay? So, this what we will also see later on today. Okay? Right. So, with wired LAN, okay, when you have two different devices that you want to connect, okay, so what you do is that you take a medium of transfer, then you connect it. Okay, it can be either wired or wireless, okay, and that is called ad hoc network. Okay, and if you wanted to make multiple users connected into a single network, what you can do is that you can use the four different types of topology that we've already seen. Mainly, you can use the star topology, you can use the bus topology, ring, and also the mesh topology. Okay, so with respect to that, okay, we can have these devices being interconnected together, and for a very short distance or within some small space area, we call it local area network. Okay, so with respect to that, okay, so we would like to know more. Although you have connected the physical one, but you have also to we need to know further on the different layers that support this transfer. Okay, so basically here we will look into the physical and the data link layer, right? So we will look into the internet evolution, the traditional internet, fast internet, gigabit internet. Okay, and then for wireless LAN also, where when wired cannot be extended further, okay, what you can do is that you can extend it using wireless local area network. Okay, we will look into the standards 802.11. Okay, and also part of it we can see also Bluetooth. Okay, although Bluetooth is not considered as a local area network, but we can also look into it. Okay, where Bluetooth we define it as a personal area network. Okay, so we will look into it later. Okay, to start with, okay, Ethernet. Okay, with Ethernet, you can have this different standard where you can say that you can have the standard Ethernet that support 10 Mbps of data transfer. Then you can have the fast Ethernet that can support 100 Mbps. Then move on, you have the gigabit Ethernet and 10 gigabit Ethernet with the respect speed that mentioned over here. Okay, and although basically when you want to support more user, the bandwidth is one of the limitation of your data transfer. Okay, so when you have your a single bandwidth that you can use, okay, say that between 0 to 100 Mbps. So you have to share it with multiple users that connected throughout the network itself. Okay, so here the local area network will define how you can share the resources. Okay, so although the LAN can be used as an isolated network to connect computer in the organization for the sole purpose of sharing, most LAN today are linked in a wide area network or the internet. Okay? So these are several internet evolution that you can see. So here, this diagram shows you the difference between the data link components and the physical component itself. Okay? So the data link is here where the data link layer is here where you actually see that the data link consists of two sub components which we defined already last week. You have the logical link control and also the MAC. Okay? So for the LLC, basically is similar to any of the interface that you wanted to connect. Okay? So then you can have the MAC, okay? And then you have the physical layer and also how it is being connected through the medium. Okay? So it defines the data link and also the physical layer. Okay, so the local area network differs only in the MAC sublayer and in the physical layer. Okay, so for any of the interface, okay, previously you can add cards, but now maybe the chip. So the chip itself can be different with the MAC and also on the physical layer. Okay, while the MAC sublayer is slightly different for each internet version, the physical layer is quite different. Okay, so it depends on how you connect. Okay. Mind you, for your current laptop, okay, or PC, usually you have two different interfaces. Okay? It can be your internet and also your Wi-Fi connection. Okay? So means that you have this perhaps two of this physical layer connection. Okay? One with the wired LAN and the other one with wireless LAN. Okay? So that is where you can see the different layers. Right. So in traditional internet, it starts with supporting up to 10 Mbps. Okay, and the basic components for the sharing of medium is use CSMA/CD. If you can recall, CSMA/CD being defined as carrier access, multiple access with collision detection. Okay, so what it means that if you have multiple users that be connected through that internet link, okay, so it will use this standard or this protocol where before it sends, it will try to identify either any other devices are trying to send, okay, but if there's nobody wanted to send, then you can send. Okay, so that is where you have the carrier access, multiple access with collision detection, meaning that you want to avoid collision detection. So with this SMACD, you will quickly back off if you sense that any collision happened between the medium of transfer. Okay? And the media are shared between all stations, and the MAC sublayer governs the operation of the access method. Right? It also frames data received from the upper layer and pass them to the PLS sublayer for encoding. And we also have learned about one persistent CSMCD as the access method. Okay, so here the traditional is use one persistent CSMACD. Okay, so this is the frame for your internet. Okay, so you have basically you have the destination address, you have the source address. Okay, and then you define what will be the length or type of your data. Okay, so you can have your data with some padding. Basically, if your data is small, okay, so you have to insert empty these bits, okay, so that you can before you send. Then you have the CRC, and at the beginning you have the printable and SFD. Okay, and each of these, okay, will you can see that it has the size of it. Okay, so the destination and the source address will consist of 6 bytes altogether. 6 bytes for destination, 6 bytes for the source. Okay, and then define what is the length. Okay, 2 bytes. Okay, and then you have a data that will define later on. And the CRC with 4 bytes. The CRC they are using the highest level of CRC. Okay, and also 8 bytes altogether for programmable and SFD. Okay, so Ethernet frame consists 7 fields. Okay, so you have the programmable, SFD, destination address, source address, length or type of protocol PDU. Okay, upper layer data and the CRC. So the actual data is the red one. The rest is just header, perhaps coming from the above. Okay, you also need to add headers for your physical layer. Okay, so the internet does not provide any mechanism of knowledging and receive frame, making it is known as unreliable medium. Okay, and acknowledgement must be implemented at the highest layer. So it doesn't have any mechanism, okay, to identify the receive frame. Okay. Okay, now we are looking at this programmable and SD. Okay, so we are looking at this programmable cannot do anything. Okay, so we are looking at this part where you have the programmable and SFD. Okay, so programmable is alert the receiving signal system to the coming frame and enable it to synchronize its input timing. Okay, so there's 7 bits that have a specific pattern. Okay, where it says that 56-bit pattern allow the station to miss some bits at the beginning of the frame, and the programmable is actually added at the physical layer and is not formally part of the frame. So basically, this is being added at the physical layer just to indicate how the receiver can synchronize with the frame that is coming. Okay, so it can identify the framing, okay, or it can synchronize the framing, and then by having the start frame delimiter as FD, okay, it will tell the station that they have a last start for synchronization, and the last 2 bits are 11 and alert the receiver that the next field is the destination address. Okay, so now when you set, okay, this one is to do synchronization, then you have another 2 bits for also for synchronization, and finally 11 and 11, 2 bits and 11, okay, can be used to make the last indication that this is the coming destination address. Okay, so these are the main one, right? And then you have the destination address, the source address, which we'll see later. Okay, but then in the same time, you have to identify what is the length of your data over here, right? So the length or time will be defined based on if the field is less than 1518, okay, and is the length field and define the length of data that the flows. Okay. On the other hand, if the value of the field is greater than 1536, okay, it defines the type of PDU packet and it can encapsulate in the frame. So basically, it will actually identify either that the length is greater or lower than this 1518. Okay, so it will define or it will give you the type of the data. Okay, and we have the data itself. Okay, and the data will have a minimum and maximum. Okay, if the information data is less than 46 bytes, okay, so you have to add padding. So this is the minimum one. So but it can also expand up to 1500 bytes. Okay, so this data can have minimum of 46 and 1500. So meaning that this frame can, if you calculate this, okay, all this plus 46 is the minimum size, okay, and the maximum you have plus all the header plus this data, so you get the maximum size. Okay, and last but not least, you use the CRC32. Okay, remember back the CRC is for correction control. Okay, so you can have this error correction being implemented in this Ethernet frame. Then we also have this one is the frame length. Okay, so basically the minimum frame length is 64 bytes. Okay, and the maximum is 1518 bytes. Okay, so these are the total size of your frame. Okay, and this is because the data can either have minimum of 46 or 1500 bytes. Okay, so this is how it is being used. For addressing, okay, you have the sender address, you have the receiver address. Okay, so this is the MAC address that we already mentioned when we talked in our lab session. Okay, it has 6 bytes. Okay, and it's in hexadecimal number. Okay, so it can also be named as network interface card address. Okay, or it can be MAC or physical address. That's the same definition. Okay. So it has 48 bytes of 60 bytes of 48 bits, okay, that written in hexadecimal. Okay. And that basically it is unique, right? On top of that, okay, since you are transmitting between sender and receiver, right? So there's a possibility that you need to send it, okay, one to one, okay, one to many, or perhaps you wanted to please broadcast it. Yes, so in the internet, it define 3 different, actually 4 different type of casting. Okay, so it can be unicast, meaning that it's one to one. Multicast, it means that selective user. Anycast is where you can again selective, but you have to be determined. Broadcast means that you need to send to everyone. Okay, so here you can say that a unicast is one to one, a multicast is one to many. Anycast means that deliver to one of the interface identified by the address, where you have this be identified before you send. Okay, this one for multicast defines the group of address, and the relationship between the sender and receiver is one to many. Okay, and you have the broadcast where you can send to everyone. Okay, so with respect to that, on your header byte, okay, so you can see that on the least significant bit, okay, you can see that the unicast and the multicast is defined by bit 0 or bit 1 on the least significant bit. Okay, so this can be identified. Okay, so here it says that the least significant bit of the first byte define the type of the address. Okay, if the bit is 0, it's actually unicast. Okay, otherwise it's a multicast. Okay, and the broadcast destination address is special case of the multicast address, and which all bits are 1. Okay, meaning that all the 6 bit is actually 1. Okay, that represent that is a broadcast. Okay, so that is what a standard Ethernet, right? But they only have a speed of 10 Mbps. Okay, so we need to get much faster, because now people request for much faster data transfer. So what they do is that they define improved Ethernet, okay, by having this fast Ethernet. Okay, so we would like to see the fast Ethernet, okay, then going to gigabit Ethernet and 10 gigabit Ethernet. So start with standard Ethernet where you use Crozier cable and also twisted pair, but going to gigabit Ethernet and 10 gigabit Ethernet, it can either use twisted cable pair, okay, but also the most medium that we use is actually the fiber medium lah. Okay, so the standard one here, okay, the standard one with 10 Mbps can also be divided into 4 categories. Okay, so you can have 10 base 5. Okay, as mentioned, the 10 means that the speed is 10 Mbps. Base is baseband transmission, and 5 here represent that it can expand up to the distance can be up to 500 meters, right? And then you have the 10 base 2, where base 2 here represent that it can goes up to 200 meters. 10 base T, the speed is 10 Mbps. Then the T represent this is a twisted cable pair. Okay, and then you have 10 base FL, where this one is using fiber. The F represent that fiber long distance. Okay, So these different standards give you different the same speed but different interface. Like 10 base 5 actually is base type of topology with a coaxial cable. Okay, you have 10 base 2 using bus topology but with a thin coaxial. Okay, 10 base T you use a star topology using your untwisted pair cable. Okay, and then you have the 10 base FL. Basically, this is a fiber optic. Okay, so the distance also will increase with base T and base FL compared to the base 5 and base 2. Okay, so this is how it is being connected during the dinosaur time. Okay, I was able to experience this during my study time, where you have this coaxial cable that you lay down this as a bus topology, and then you have to clamp your transceiver on this cable, okay, bus cable, and then you can extend it to your devices lah, right? To either your end user or your server. Okay. So this is how it is being defined. So you can see that it uses 10 base T standard with a thick Ethernet, okay, and or a thick net, okay, and then the distance will only expand to 500 meters, right? And then you have the 10 base 2, okay. Now you use thin Ethernet, okay, and the distance can up to 185 meters, almost to 200 meters. Okay, so now they use this. I can't remember what they call this, but this one much simpler to be connected compared to this one. But basically, on the physical connection, basically, you run this through different room. Okay, and if your room is over here, what you need to do is that you have to cut this cable, and then you have to attach this transceiver, okay? And then you can re-communicate with others. This one you just clamp it. Okay? You have to kind of put some slice of it, and then you can see the the coaxial itself. Okay? And then you can connect it through this transceiver itself. Okay? So this is very old technology that being used, okay? And you can see that you have the end cable to stop the data from sending through the rest of the world. Then for 10 basically now you use the blue cable, okay, like the one that we are using right now. You use the twisted pair Ethernet, right? And you use based on star topology. Okay. Then for twisted T, basically it can goes up to more than the one that we have with the previous two. Okay. And with respect to this is much more simpler. Okay, because you just need to have a connection between this and your hub or a switch, basically. And then with respect to that, it doesn't interfere the rest of the communication compared to the previous one, where when you want to clamp, perhaps the communication will be down for for some time, and then when you are ready, then you can transmit. Okay. Then for FL, basically you are using fiber optics to be connected to your other interface. Okay. So these are the traditional or the standard Ethernet of 10 base. Okay, so if you compare this, okay, these are the comparison. The line coding here is using Manchester. I think it's using Manchester City rather than Manchester United. It's just a joke. Okay, so it's using Manchester encoding. Then the distance, if you want to compare, and the medium. Okay, so if the kind of question be asked to you, what's the difference between 10 base 5, 10 base 2, 10 base T, and 10 base F? So perhaps you can say these are the comparison except the line coding itself. Okay, so you can see that the thickness, the type of cable, and also the distance. Okay, so here it can go up to 100 meters, and this one can go up to 2 kilometers. Okay, And then when they started with this internet, basically everyone has the same bandwidth, okay? And you have to either use kind of a time base, okay? Or perhaps sharing the different frequency on different time, okay? So here you can say that this is the sharing of bandwidth, meaning that if you have two different sender, okay, or two different stations, okay, so you have to share the station between the two different stations itself. Okay, so when the first station is transmit, the second station will be on hold. Okay, when the second station is transmit, the first station will be on hold. So basically, here you are sharing the bandwidth. Okay, so you look at this as a very difficulties if you want to expand to much more number of users. Okay, so here it says that bridge internet. The first step in internet evolution was the division of LAN by bridges. Okay, where bridges have two effects on the internet LAN. Okay, so these are the two effects. One is they raise the bandwidth and separate collision domain. Okay, so we will see later. But basically, rather than you have a same bandwidth, okay, being shared for one total number of users, say 10 number of users, why not if you can separate them into two different networks, okay? And the bandwidth is being used fully for network 1 and then fully for network 2. And then you can bridge it together. Okay, so the idea that using the bridge, okay, later on you see that it's using switches and also routers to do this. Okay? With that, okay, so it will raise the bandwidth. Okay? Meaning that rather than if you have 10 users, then 10 Mbps means that one user will have 1 Mbps. The bandwidth is very low compared to just 5 users in network 1, 5 users in network 2, and each user, each bandwidth is 10 Mbps, meaning that you have raised to twice of the bandwidth. Okay? So that is what it means by the raise of bandwidth. And then separate collision domain with this time sharing baseband technology. Basically, you have to consider multiple users. Okay, so if we have 5 users, meaning that there's a possibility of collision between all the 5 users is much more. Okay, compared to if you have small number of users. If you have much further number of users, then there's more collision. Okay, so with the bridge internet, basically it will solve these two problems: the bandwidth and also the collision domain. Okay. So what is rising of bandwidth? Okay? So you mentioned here, if two stations have a lot of frame to be sent, they probably alternate this usage. Okay? So as mentioned just now, they use different time to transmit using the whole frequency band. Okay? And this is when you have two. So when one station is sent, the other refrains from sending. Okay? So we can say that on average, each station sends at the rate of 5 Mbps, meaning that 10 Mbps divided by 2 means that in average you have 5 Mbps. Okay? So this is not good. Okay? So a bridge, okay, basically divide the network into 2 or more networks. Okay? So you can divide it into 2 or much more networks. And with respect to that, bandwidth of each network is independent of the number of users, total number of users. It depends on the number of users for that specific network itself. Okay? And for example, in figure below, a network with 12 stations, okay, is divided into 2 networks, each with 6 stations. So rather than you have the whole thing on a single network, okay, so say that this user wants to send, it has to make sure the rest, the 11 other users is not sending. Okay? So up to that. Compared to here, when you want to send between this user, okay, unless you want to send to the next unit or the next LAN, okay, so what you need to do is that you just need to identify the other 5 not sending. Okay, so with respect to that, the contention compared to this network and this network, this is much more lower. Okay, so in network with a heavy load, this station typically is often 10 of 6 Mbps. 10 is the say that this is 10 Mbps. Okay, you divide by 6 for this. Okay, compared to this where you have to divide by 12. Okay, so this one is much more lower bandwidth compared to this one. Okay, so now you have the bridge that being divided into these two different networks, right? And you can actually expand further rather than just 2. You can also go for 4. Okay? So now, rather than the 10 Mbps for whole this divided by 12, so the 10 Mbps divided by 3 for here. Okay? So same goes for each and every different domain. Okay? So you can see that the bandwidth can increase. And then the other advantage is that separating collision domain, okay, the collision domain becomes much smaller and the probability of collision is reduced. Okay, so that is why is one of the advantage of this, where you can actually have much lower collision domain. Okay, so without bridging, 12 station content for access to the medium, while bridging only 3 station content for access to the medium. See, as I mentioned just now, out of these 12, you say that this user wanted to send, they have to contend or they have to fight with the rest of the PC or the user itself, okay, to use this shared bandwidth. Okay? But here you have just to fight with 3 people. So which one is better? Fight with 3 people or fight with 11 people? So this one is much better than this one. So it shows here collision domain in a non-bridge and bridge network. This one is without bridge and this one is with bridge that we configured into 4 different segments or domains. Okay, so a bridge will help to separate the bandwidth, but basically you can further improve it by using switch. Okay, so when you do your lab experiment, okay, using the packet tracer, Cisco packet tracer, you see that we have different network devices, like basically you haven't seen on the hub. Okay, basically the hub is just to replicate whatever the packet that you receive from network 1 to the network 2. Okay, a bridge is just connecting the same network. Okay, a hub is to extend it. Okay, and then you have a switch. Okay, and on the higher end you have the router. Okay, so based on the bridge just now, you can also have a switch Ethernet. Okay, so extending from the bridge LAN, okay, you can have a switch LAN, okay, instead of having 2 or 4 network. Why not have N network, where N is the number of stations on the LAN? Okay, so now you wanted to have more than a single network. Okay, so you have a switch that can actually support N number of users. Okay, so in other words, if we can have a multiple port bridge, why not have an N port of switch? Okay? In this way, the bandwidth is shared only between the station and the switch. In addition, the collision domain is divided into N domains. Okay? And a layer 3 switch is an N port bridge with adding sophistication and allow faster handling of the packet. Okay? So when we do the simulation itself, you see that on the switch we didn't do any setting. Okay? So it's basically it will try to send the information at the beginning to if you receive from one port and it has other outstanding outgoing port, okay, it will replicate the packet to the all outgoing port. Okay? But later on, when it's already identified where it can be sent, okay, it will send it directly. But for a router, basically before it sends to any of the output interface, you need to do the configuration first. So that is where in router you have this routing table. Okay, so this routing table will indicate how it be connected. It can only connected to those who are physically. It can only know those who are physically connected to it towards it. Okay, but if you want to connect to a different LAN, so you need to do some routing table configuration, where in lab 5 we see that, or lab 4 we see that we use a static, we can use default routing, or we can use some dynamic algorithm, okay, of routing, where we see what we call RIP, not rest in peace, but it's actually routing information protocol. Okay, so with the RIP, basically it will dynamically identified how it can be routed by giving the instruction for the router to get further information. Okay? So with respect to that, now the domain can be subdivided into different subdomain. Okay? So the bandwidth here is not being contended with this and so forth. Okay? And also the collision domain will be within that specific domain only. Okay? And internet also, okay? Since you have to send and receive, so it needs to identify either it's a duplex or full duplex or half duplex. Okay? So in 10-base-5 and 10-base-2, basically is half duplex, but for the rest of it, it will actually use the full duplex switch. Okay? And also you can see that flow error control in full duplex switch internet and sublayer called the MAC control is added between this LSC sublayer and the MAC sublayer. Okay? So you need to have full duplex. So you have a full duplex means that you can transmit and receive using two different links. Okay? In a full duplex switch internet, there's no need for the CSMA-CD method because each station is connected to the switch via two separate links point to point. Okay? Because you are not connecting in between anything between this. Okay? So you just need to have a point-to-point connection. Okay? And each station and switch can be sent and received independently without worrying about collision. Okay? So for further, for full duplex, we don't use the carrier sense anymore. It's a point-to-point. Then we have fast internet. Okay, 100 Mbps. Okay, represent as the fast internet. Okay, the main idea is that to keep the MAC sublayer lah. But you can actually you can differentiate it by the physical layer. Okay, the access method is the same, CSMA-CD. Okay, full duplex fast internet. If it's being used, there's no need for CSMA-CD. Okay. The format, minimum maximum frame length and addressing are the same for 10 and 100 Mbps, the same as the previous one. Okay, and new feature added to fast internet is called auto negotiation. Okay, so that it can further improve it. Okay. So auto negotiation, okay, allows a station or hub a range of capability where it allows the device to negotiate the mode and the rate of operation. It was particularly designed for the following purpose: to allow incompatible devices to connect to one another, to allow one device to have multiple capabilities, and to allow a station to check the hub capabilities. So basically, before you send, okay, you can negotiate. If you can go with higher speed, then go for it. Okay? If you are able to do that, perhaps the other device is at the slower part link. Okay? So you have to use the lower bandwidth itself. Okay? So that is on auto negotiation. And for fast internet, okay, you can actually divide it into two. One is base X. X here represent that is a fiber connection, and base T4 is a twisted pair with 4 cables. Okay, and for base X here, it can be divided into TX and FX. So the TX is using the twisted. So base X here is twisted pair, but with 2 cable, and the FX here is using fiber optics. Okay, the speed of here that we use is 100 base. Okay. Here you are using twisted pair with 4 wired. Okay, so these are the 3 different standard for your fast internet. Then you can also have 1000 Mbps, and this one we call a gigabit internet. Okay. Again, we would like to keep the MAC layer, but actually it's impossible. Okay. So when you have the 1 gigabit rate, okay, that was no longer possible to maintain the MAC layer. So you have to do some changes on the MAC layer. And the gigabit can have 2 different approach. One is half duplex using the CSMA-CD, and full duplex where you have the point-to-point connection lah. Okay, and okay, so this is for the gigabit internet. Then it can be defined of 4 different types. Okay, so you can have the SX, okay, LX, CX, and base T. Okay, the base T twisted cable, you know, this is using copper wire, 2 wire. Okay, so the base CX here designed using STP cable. Okay, but actually this one is being defined but not being properly used. Okay, then you have the base T over here, use 4 wired. Okay, is same as base T4 on the fast Ethernet. Okay, and then you have the SX and LX. So here is for short wave fiber and a long wave fiber. Okay, so you have a fiber X over here using a fiber where you have the short wave and also the long wave. Okay, so these are for different medium of standard for your gigabit internet. Okay, then you can also have the 10 gigabit and so forth. Okay, but however, it depends on the when you choose your interface. Okay, basically you also need to know that your device can support it. Okay, so one of it is that you need to make sure that the interface is okay, and then if you want to implement it, you need to know, is it compatible with the network itself, your switch and so forth. Okay, so that is on internet, right? Okay, so next, when we wanted to have the internet, okay, basically we just need to be connected, okay, between each other. But then later on, the requirement have increased, whereby rather than you have to do it connected physically, why not be also able to do it wirelessly? Okay? So in a wireless environment, at the beginning, it defined 2 different networks. One is the wireless LAN, okay? The other one is a mobile network. Okay? But now most of it is being combined together. Basically, when we have the second generation of mobile network, where you have your mobile phone, it's totally different from the one Wi-Fi that we will discuss further later on. Okay, so it's totally have a different mobile network, okay, compared to the wireless LAN. Okay, so the mobile network itself has its own journey. Okay, it starts with the first what they call it, first generation. Okay, then you have the second generation, third generation 3G network. Okay, the 4th generation right now, we are using the 4th generation. Moving on to the 5th generation. Okay, and for those who actually know that I was going for a conference last week, okay, that purely based research on wireless communication. They are talking about 6th generation and so forth. Okay, going from 3rd to 4th generation is totally evolution. Okay, but 4th going to 5th, okay, basically is to increase the speed. Okay, to reduce the delay or the transmission link. Okay, so that you can have a very smooth real time, because with 5G later on, okay, so the delay will be very minimum, because you want to have a real time. For instance, if you have an application like self driving car, okay, so it cannot have any lapse of time. So it needs to have a very smooth real time, okay, without any interruption. Okay, if it doesn't have any connection when you are driving, then perhaps there can be some catastrophe out of that. Okay, so it's different mobile communication to a wireless local area network. Okay, so now we would like to talk about wireless LAN. Okay, but you have to separate it with your mobile network itself, which is totally different. Even when on your phone right now, you can see that you have your data link, okay, communication data, and also you have your Wi-Fi. Okay, Wi-Fi is actually based on wireless LAN, where the mobile station is basically separate network from your wireless LAN. Okay, So now we can talk about the wireless LAN. Okay. The technology standard is based on 802.11, right? Okay. This also sometimes called wireless internet. Okay. And also Bluetooth can be one of it, but usually I define it as a personal area network or PAN. Okay. So it also covers the physical and data link, meaning that if you want to have your device be connected to a wireless network, wireless LAN, what you need to do is that you just need to add an interface card, which is actually define the physical and the data link layer. Okay? So that is how it's being defined. And then it has two different services. Okay? So what we call the basic service and what we the other one called extended service set. Okay? So the basic service meaning that it be connected with a single access point, but extended service meaning that you can be connected to a whole range of different access points and you can still be connected together. Okay? So 802.11 defines BSS as the building block of a wireless LAN. Okay? As I mentioned, it needs to consist both, which is the stationary or mobile wireless and also an access point. Okay, so we need to have this access point to communicate. Similar to internet, in a star network, you need to have a switch or hub, right? You need to connect to that point to point. Here means that the access point will also connect your end user to the access point, one point to point. Okay, so a BSS without an AP is a standalone network and cannot send data to other BSS, and it is what is called an ad hoc architecture. Okay, so you can try this on your own devices. Okay, you can connect your Wi-Fi to your any access point. Okay, that available. Okay, but in the same time, there's a connection that you can do ad hoc connection between your two end devices. Okay, you can try like Wi-Fi transfer application where actually it's connected ad hocly to your two devices without having to access this access point, and you can transfer your data. Another example is that perhaps some of current cameras, DSLR cameras, can be connected to your mobile phone, then you can transfer data between those two. Okay, so that one is called ad hoc. Okay, and this architecture station can form a network without the need of AP, and they can locate each other and agree to be part of the BSS. Okay, so the BSS is itself needs to have both the stationary mobile wireless terminal and also the access point, but the mobile terminal or stationary terminal itself can be connected together using this ad hoc mode. Okay, okay, so this is the BSS with an AP. Okay, and then this represents the ad hoc network where it is kind of what we call mesh connection. Okay, we can say it ad hoc or mesh connection. Okay, because it can be connected between each other without any access point. Okay, but the basic service will need to have this access point, and this access point can be extended to your internet. Okay. Whereas for the extended service set ESS, okay, it can made up of two or more BSS with APs. Okay, so means that it can be connected together to form a much larger network. For instance, like what we have in MMU. Okay, so when during one of the experiment, okay, where I say to you, some of you, rather than you need to connect to MMU Wi-Fi, you have to connect to your own access point of your mobile to do the experiment. So basically, because MMU is using the ESS, what we wanted to have on the experiment is using the BSS. Okay, so basic service set. Okay, with ESS, the network is very broad, okay, because you can have multiple Wi-Fi address, and also you can actually have one what they call it a control device that managing all the Wi-Fi connection. Okay, so that whenever that you hook to MMU network, you will still have the same IP address when of the past one. Okay. So BSS are connected through a distribution system, which is usually a wired LAN. Okay, and it can be does not restrict the distribution system. It can be IEEE LAN or such as internet. So meaning that it can be connected to the internet. The ESS use two types of station, mobile and stationary, and the mobile station are normally stationed inside a BSS, and the stationary station are AP stations that are part of the wired LAN. Okay, so it can be a combination of wireless and wired, as we mentioned over here. Okay, so it can be your access point that be connected. And one of the beauty of this is that actually you can move from one AP to another AP. So basically the access point, if you already known that it can cover some range of distance, right? So when you are moving out of the range of the access point, then you don't have that coverage. But the beauty is that now you can have other access point that overlap. Okay, so perhaps you are here, so you can access to those two. Okay, but later on you'll see that with Wi-Fi, there's a possibility that your connectivity when you move from one AP to another AP, there's a potential that you don't continue the connectivity. What does it mean? It means that when you are playing a video, one of your Korean movie, okay, so you move from here to here, there's maybe one period of time where the movie will stop because there's no streaming or network capability, and then when you move to this next AP, the movie will continue playing. Okay, so there's no connectivity, but this doesn't being accepted for mobile communication. So for the mobile communication, using your mobile network, basically you will have what we call handover process, whereby you will still have connectivity when you move from one base station to another base station. Okay, so these are the extended services. So when BSS are connected, we have what is called an infrastructure network, and this network station within each of one can communicate with without the use of any AP, and communication between these two stations in two different BSS usually occurs via two APs, and a mobile station can belong to more than one BSS at the same time. So this is what I mentioned, is that this if it's a fixed one, then you don't have any problem. But if you have your device that can move on, so it can actually get access to any of this AP and be connected to this distribution system. Okay. And this is what I mentioned. No transition BSS transition, BSS transition, and ESS transition mobility. Okay. So sometimes, okay, when you are using some different network, okay, so there's a possibility that a station with no transition mobility, meaning that mobility is either station not moving or moving inside a BSS. Okay? So there's no transition when you move from one base station to another base station, or one access point to another access point. And the station with BSS transition mobility can move from one base station to another, but the movement is confined inside the one ESS. Okay? So there's a limited access. Okay? And the station with ESS transmission mobility can move from one ESS to another. However, 802.11 does not guarantee that communication is continuous during the move. Okay, so this is what I mentioned about the handover process, okay, where you have to actually continue the connectivity while you move around. Okay, but this is not very alarming, because local area network is very small, right? So you have one base station over here, then the next site is another base station. Perhaps you're just walking maybe a very small period of time, okay, then you can get connection. But when you talk about mobile communication, you are driving a car, okay, and you're moving from one destination to another destination, and you have to pass through a lot of base station. along the highway, then that is alarming if you don't have this continuous connectivity. Okay, so basically, it's not that challenging, or it's not that problem with this transition for a wireless LAN. Okay. Right. So for a wireless LAN, basically, you can all be connected without any access point. Okay. Based on this, we would like to identify few problems. One is the hidden station problem. The other one is what we call overexposed. Okay. So the first one of the problem is that say that you have these three devices, right? And you wanted to connect, and you have a connection between these three devices, right? This one where A and B perhaps can be connected into a single range, and A and C is being connected into a single range. Okay? But A is overlapping between these two coverage. Okay? So there's a possibility that when B wanted to send to A, C doesn't know that B is sending with respect to the carrier sets. So then if B is sending the packet to A and C sending packet to A, then there's a collision will happen. Okay, so B and C are hidden from each other with respect to A. Okay, so A can hear from both, but B and C are actually hidden from both of them. Okay, so station, however, is covered. Both C and C can hear. Okay, so that I already mentioned that this hidden station problem is when these two different coverage, A is overlapping, A and B can communicate, B cannot be communicate to C, A can communicate to C. So that is where one of the problem happen. So when this happen, basically you send B to A, okay, and basically you wanted to make sure that you can also make C listen. So you use this RTS and CTS. Okay? So the RTS and CTS here, okay, whereby request to send. Okay? So when B wanted to send something, it will request to send, okay, and it reach A, and A will actually send what they call it confirm to send. Okay? So the CTS, RTS, and the CTS, whereby you can when you have the CTS clear, CTS is clear to send. Okay, so meaning that it indicates to A, C that although it's on the hidden side, that it cannot send because B is trying, or other station are trying to send to it. Okay, so that is how you solve the problem of hidden communication. Okay, then another problem is for exposed station. Okay, now you can see that you have these four different devices. Okay, A be connected to B. Okay, C be connected to D. A can be connected to C. Okay, so now you can actually set from A to B. Okay, and then you can use the CTS and RTS and CTS. But basically, it doesn't affect if you wanted to send from C to D. Okay, so now with C and D can communicate, it's overexposed because now B will send that to A, that saying that I want to send from B to A. Okay, and then send a clear to send message, but actually C and D is not affected with that transmission. Okay, so what you can do here is that you can try to make changes to the CTN and RTS. Okay, by having this specific network handshaking between A and B. Okay, because it's just between A and B, and the rest mentioned that this is for A and B. And if you have C and D communication, yes, you can actually retransmit that without having to stop because it doesn't affect the other two devices. Okay. So both station D and A measure the RTS, but station A This is in the standard state and not the receiving state. And station D, however, respond with a CTS. So station C starts sending data to station D. Okay, so now you can have this communication between both. Okay. Right. So then we have the Bluetooth. Okay. Bluetooth is another standard. They use 802.15. Okay. Ethernet 802.3, Wi-Fi is 802.11, this is 802.15. Okay, so it used an ad hoc network. You don't have to have any access point to be connected. Okay, and it's sometimes called gadgets, okay, and also called Piconet. Right, so it can extend to internet connectivity. Okay. If you have one of it being connected, okay. And again, as it mentioned, it's 802.11.15 standard, and it is called personal area network. And for Bluetooth, okay, it needs to have this master slave. Okay, it can pick up to 8 stations in a network. Okay, but one of it needs to be a master, and the other need to be slave, right? And then when you have one as a master, the other as a slave, if you want to connect one of the devices, one of the slave, to be connected to another 7 of it, the slave can now become the master for the second network and so forth. Okay, so you can have much further connection. Okay, so Bluetooth defines 2 types of network: Piconet and Scatternet. A Bluetooth is called a Piconet or small network. Okay. Where it can have 8 stations with one of it as a master, and then the slave, the other as the slave, and all secondary stations are synchronized with the clock and hopping sequence with the primary station. Okay, meaning that they have to connect to the primary before can be transferred to the other slave. Okay, and the communication between the primary and the secondary can be one-to-one and one-to-many. Okay. Okay, so you have one primary and another 7, okay, secondary or slave, we call it. And although Piconet can have a maximum of 7 secondary, you can have additional 8 secondary can be in the park state, okay? And the secondary in the park state in synchronous with the primary but cannot take part in the communication, is still moved from the park state. And finally, we can say that Piconet can be combined to form what is called a scatternet. Okay? This scatternet, where you can say that the secondary, the one that I mentioned just now, can now become the primary to another Piconet. Okay? So then you can extend, okay, to 2 of the Piconet, and you will see something like this, where you have this one Piconet. Now one of the secondary of this Piconet is become the primary of the other Piconet. Okay. So Bluetooth, the distance is very short. Data rate is only 1 Mbps. Okay. And this means that there is a possibility of interference within 2. Okay, because the frequency here 2.4 gigahertz. Because 802.11 for your wireless LAN also using 2.4 gigahertz. Okay? So there's possibility that you can have interference between them. Right. So with respect to what we have mentioned just now, okay, I think the one that I didn't show is the wireless LAN different between the different wireless LAN. Okay, but you can look into it in details. Okay, so you can see that to have connectivity within a local area network, you can see that we can use a wired local area network, okay, and a wireless local area network. And within the local area network itself, it defines the logical link control, medium control, and the physical layer of it. Okay. Then we also have seen the different type of Ethernet. Okay. So it goes from the standard Ethernet to fast Ethernet, gigabit Ethernet, 10 gigabit Ethernet. Okay. and this is based on 802.3, okay, standard. Then we also see Wi-Fi with a standard 802.11. It can have three different frequency, 2.4, also 5 gigahertz and 60 gigahertz. Okay, and it can be connected either through access point or without access point. And then also we have seen about the personal area network, okay, where Bluetooth is predefined as 802.15. Right? Right. So with respect to that, I think that's the end for my sharing session. So I'm open if you have any question. But before that, I just want to answer a few of the questions. On the quiz 2, I will try to quickly make available of the marks, okay? And perhaps by next week, you guys can see both lah, the combination of marks of your quizzes. Okay? Then we also have Dr. Kanan has already mentioned about your test one, which supposedly being assigned for this week, but he wanted it to be on next week, next week, which is on the 28th of December, right? So you by that time, I think you guys will be online. Okay, so the quiz, the test will be also online. Answering some of the questions from your friend. Is it multi-choice MCQ? No, it will be what they call it. You have to answer it. You have to write something on that. Okay. And then any calculation, I haven't seen the question, but as the lecture note already been shared to you, yes, there possibility there's some calculation and so forth. Okay. Good question. Do you have tutorial class for today from 3 p.m.? Yes, we have. Okay. Now, another thing is that for those who under my tutorial or lab session, you have to submit lab 5, okay, that already, not already lah. The lab 5 itself, so that it can be considered as your attendance for last week, okay. If you, for those who are on Monday session, then during public holiday, I've already shared with you a recorded of the explanation of the two labs, okay. So perhaps we can use that. Those who already also on medical leave or quarantine and or do not attend for today's this week's session, please do submit tutorial 4 also. Okay, so that it can be considered for this week. Okay. Okay, so I answered Zaman side sheet for today's tutorial. Okay. Any other question? No. I think everything is clear. Why do you make it accept through classroom itself? Okay, I will do that also. Okay. Thank you for the suggestion. I will try to make it on the classroom. Right. Anything else? Just for your curiosity. Come. Press the camera. I think the camera doesn't want to follow me. Doesn't want to follow me. Yeah. TT7L, which is on where? When is this TT7L? Those who are on Monday, you have to submit your lab 4 and lab 5. The rest that have physical classes with me, you need to submit only lab 5. answer your question. We need to submit the working lab for lab file. If it doesn't work, I consider it as no submission. Do we submit the PDF for lab file as well, or do we only submit the packet tracer file? Only the packet tracer. I don't want to see the PDF file. Only the packet tracer. So basically, if you guys already have it working, okay, perhaps you can make the recording. Okay, if later on, when I check that your packet tracer is not working, I will ask you for you to show it to me. Okay, one of it is that you can use a recording of your simulation, and you can show it to me later on. Then, if you already submitted, it's okay. No problem. But if you don't submit the packet tracer file, then you have to resubmit. Okay. Anything else? Dah bye dah. Bye. Where are you going, Zakwan? Ahmad Zakwan, where are you going? You already buy. Where are you guys going for your holiday? Going to bed. You don't have any class after this. Balik kampung. Where to? Oh, no class. Kaipin, yes, please resubmit, but wait for me to give you the Google Classroom rather than the email to me. All right. So I hope that everything is on track right now. Okay. So if there's no further question, I'm looking forward for your submission. For those who have to submit Lab 4 and Lab 5, so do submit. Those who need to submit Lab 5, please do so. Okay. All right. Thank you. And I'll see you on the next.